Hello guys, my name is Craig and welcome to Peri Solutions. So today we're going to look at module 2 of factorization, and this is looking at factorizing quadratic expressions and looking at the difference of two squares. So to start off, let's just look at these 9 questions. So we want to look at how we factorize quadratic expressions. So with number 1, we've got x squared plus 6x plus 8. So what we do, a quadratic expression, this is an expression of the form ax squared plus bx plus c. So what we do is that we multiply. First step is that we multiply first term and last term. So we multiply first term and last term to get 8x squared. Now next step is to find two terms that when we multiply we get 8x squared, and when we add them we get the middle term. So next step, we want to find two factors. When we multiply them they give us 8x squared, and when we add them they give us the middle term 6x. So we see these factors, we've got 2x and 4x. Right. So if we say 2x times 4x, we get 8x squared. And when we say 2x plus 4x, we get 6x. So 2x plus 4x, this gives us 6x. So now in place of 6x, we shall put 2x plus 4x, such that we've got x squared plus 2x plus 4x plus 8. This standing for the 6x. Then now we split this 4-term expression to have two separate expressions which we can factorize. So we see here that for the first expression, x is common. So x, we get x plus 2. If we factor out x into x squared will give us an x. Then plus x into 2x will give us a 2. Then plus, for 4x plus 8, we see that 4 is common. So 4 into 4x, we get an x. Then plus 4 into 8, we get a 2. So we see x plus 2 is common there. Factoring out x plus 2, we shall say we've got x plus 4 there. Because x plus 2 into x times x plus 2, that's x. And then x plus 2 into 4 times x plus 2, we get a 4. So this is how we factorize a quadratic expression. Now I would like to continue. So let's move on to number 2. Okay, so number 2, we are saying that we've got x squared minus 5x minus 24. So multiplying the first and the last, we've got minus 24x squared. Then these two factors that we want, when we multiply them, they give us minus 24x squared. And when we add them, they give us minus 5x. We've got minus 8x plus 3x. So these two factors are minus 8x and 3x. So we substitute this in place of the minus 5x. So x squared minus 8x plus 3x minus 24. Split that, we factorize separately. Here we see x is common. X into x squared, that's x, minus 8 into x, 8x, that's an 8. And then plus, for 3x minus 24, we see that 3 is common. So 3 into 3x, that gives us an x, and minus 3 into 24, that gives us an 8. So we see x minus 8 is common. X minus 8 into x times x minus 8, that will give us an x, plus x minus 8 into 3 times x minus 8, that will give us a 3. So this is how we factorize number 2. Now let's move on to look at number 3. Okay, so for number 3, we've got a squared plus 14a plus 45. So if you multiply the first and the last, we get 45a squared, which means these two factors that we want, when we multiply, they give us 45a squared, and when we add them, they give us the middle term which is 14a. This will be 9a plus 5a. So 9a times 5a, we get 45a squared. Then 9a plus 5a, we get 14a. So in place of 14a, we shall put 5a plus 9a. So a squared plus 9a plus 5a plus 45. And then we split this, we factorize separately. So here we shall factor out a, that is common. A into a squared, we get an a, plus a into 9a, we get an a, we get a 9, right? Then plus, for 5a plus 45, we see that 5 is common. So 5 into 5a, we get an a, then 5 into 45, we get a 9. So we see that a plus 9 is common. So we shall factor out a plus 9. Then a plus 9 into a times a plus 9, we get an a, plus a plus 9 into 5 times a plus 9, we get a 5. So this will be the result that we get after we factorize number 3. Now let's look at how we factorize number 4. Allow me to erase this. Okay, so now for number 4, we've got 3x squared plus 8x plus 4, like that. So multiplying the first term and the last term, we get 12x squared. And the two factors, that when we multiply them, they give us 12x squared. And when we add them, they give us 8x, which is the middle term. This is 6x and 2x. So if we say 6x plus 2x, we get 8x. And when we say 6x times 2x, we get a 12x squared. So in place of 8x squared, which is the middle term, we shall put 6x plus 2x, such that we've got 3x squared plus 6x plus 2x plus 4. And then now we shall split that 4-term expression to have two separate expressions. Then we can now factorize them. So for this one, we see 3x is common there. So factoring out 3x into 3x squared, we get an x, plus 3x into 6x, we get a 2. Then you put the plus sign that is there. For 2x plus 4, we see that 2 is common. So 2 into 2x, we get an x. Then 2 into 4, we get a plus 2. So we see x plus 2 is common. So we shall factor out x plus 2. Then now we shall say x plus 2 into 3x times x plus 2. We get a 3x. Then plus x plus 2 into 2 times x plus 2. We shall get a 2. So this is the result that we get after we've factorized the quadratic expression for number 4. So now I would like to continue to look at number 5. And then for number 5, 6, 7, and 8. Now we have to apply what we call the difference of two squares. Why? Because we say a quadratic expression is the expression of the form ax squared plus bx plus c. But now for these, as you can see, we only have two expressions. We don't have the middle term. So now for number 5, x squared minus y squared. So the difference of two squares only applies when we've got two terms for which we can find their squares, and the middle term for those two terms must be a negative sign. Then we can apply the difference of two squares. So we know that the square of x is x, then the square of y is y. So we say x minus y, then x plus y. After we expand this, we'll get that. Then now for number 6, we are saying we've got 4a squared minus b squared. So we're saying that the square for 4a squared is 2a, right? Minus b squared, which we say 2a minus b times 2a plus b. So this is the final result that we get for this. And now for number 7, we've got 3x squared minus 27y squared. As you can see, we can of course find the square of 3x squared and as well for 27y squared, but this won't be a perfect square, right? So what we do is that first of all, we can factor out 3, which is common, and then we get x squared minus 9y squared. And then now we know that for this expression, this is a difference of 2 squares, which we can further on factorize to get x minus the square of 9y squared is 3y. So x minus 3y, x plus 3y. Like that. So this will be the final result for number 7. Then for number 8, we've got 25x squared minus 4y squared. So the square for 25x squared is 5x, right? Squared, 5x. Then minus the square for 4y squared is 2y. Such that we've got 5x minus 2y, then 5x plus 2y. So this would be the final result after we factorize number 8. Now let's look at number 9. Allow me to erase just this whole part. Okay, now I would like to look at number 9. Okay, so now to factorize number 9, we've got 12x to the power of 3 minus 3xy squared. So as well, we have to first factor out the common factors. So here we see that 3 is common, and then as well x is common. So we can factor out 3x. 3x into 12x to the power of 3, we get 4x squared. Then minus 3x into 3xy squared, we simply get a y squared. And then now for this expression inside the brackets, we can see that there's a difference of 2 squares. So we now have 3x. The square of 4x squared being 2x minus the square of y being y. Square of y squared being y. And then here we say 2x plus y. So this will be the result that we get after we've factorized number 9. Okay, so this was simply looking at how we factorize quadratic expressions and as well how we deal with the difference of 2 squares. Please don't forget to leave a comment, drop a like and subscribe. Thank you.